Hello everyone. This is going to be the first video of Refraction and Lenses lab. So to do this lab, we're going to use two virtual labs. First one is going to be called Bending Light, and I'm going to start it. It's going to take a while. So this Bending Light virtual lab has three parts. First introductory part, and then prism, and then more tools. Well, eventually we're going to work with more tools, but I want to go through all three parts just to show you what we can do. So what we have over here is a source of light. Source of light, you press this red button, and that's a light ray. And what we have material on the top is air, and they write down refraction index equals to 1. Material on the bottom is water, and refraction index is 133. That's what you are supposed to copy in your table. Well, you can move these sliders and change actual material. For example, you can make it water on the top or glass. There are three materials which are defined, and you can actually choose any other refraction index between. What else do we have? Well, there are two ways to represent light. One is ray, one is wave. I'm not going to use wave, but it's interesting to see how it looks. What we see is light wave, and this red colored lines are kind of ends of the one wavelength. I'm going to move back to rays. What else do we have? Well, we can move actually this source of light up or down and do something like this, something like that. With a faint line over here, it's a reflected ray. We're not going to consider it, but you probably can see that the angles of incident and reflected ones are same, and refracted is slightly different. We also have some tools, for example, a protractor you can bring over here to measure angles. You see that protractor has 0 in the middle. Normal protractors have 0 over here, right? But this protractor is convenient to us. For example, right now, incident ray has like 30, 40, 45, about 45 degrees, and I can move it a little bit higher and make it exactly 45. And I don't want to work. And my emergent ray is already around 34 degrees, right? We measure in degrees from normal line, not like usually we measure it from horizontal line. Well, that's introduction. We're not going to deal a lot with introduction. If you wish, you can do all the lab in introduction. You can actually do all the experiments over here. But I want to show you some other parts of this virtual lab. Here, we're dealing with different types of prisms. Prisms are used to refract light. For example, I'm going to put a prism in front of this light source. You see that after coming into the prism, it's refracted. It's refracted one more time and goes this way. So it's very bent. You can do actually multi-light like this and see that the beam wide over here, much more narrow over here. Or you can do a sunlight. Sunlight is going to be a white light, right? While you are having the red one, actually it's going to be the red light beam. And you can change the color over here if you are interested. You're going to see that different colors are bent different ways, right? You see that the blue color is closer to the prism and the red color is farther away from the prism. Why I'm doing the prisms? That's not in our lab. But two things are in our lab, and they are lenses. Well, in our lab, we're going to deal with only one type of a lens, which is going to be a convergent. But actually, there are two types. Let's see how this is, well, approximately a lens. It's not actually a lens, but approximately. It has one curved side and one flat side. Let's see how the light goes through the lens, which is, I'm going to move this a little bit up, make still parallel light. You see how it bends toward the like line over here, toward the horizontal line. So light which goes through the middle is not bent, but higher you go, more it's going to be bent. And same is going to happen if you're moving down. You see? So eventually you are going to have so-called focal point. Let's see, you see, you have parallel beam that bends over here and converges somewhere here. This is called focal point. We are going to need it for the second part, lenses. But in lenses, we don't have nice demonstration like this. So it's nice to see it over here. Well, this is convergent lens. It means that it takes parallel light and converges is somewhere behind in one point. Well, it's then diverges, of course, but we do have this point of convergence. Let's see what is going to happen if the lens is a different one. Well, this one does not look like a lens, but actually this is normal lens for those people who have myopia. For example, like me, I'm wearing -6 diopters. That's my type of a lens. Exaggerate. You see what happens to the light. Parallel light goes through the lens and actually diverges. So if you have your eye over here is going to converge all these beams somewhere in front. And actually the image is going to be a virtual image sitting in front of the lens. Okay. Well, that's all about this part of the lab, just to see how lenses are working, to demonstrate lenses and prisms. Now, more tools. More tools is going to be actually our working part of the lab. So in more tools, that's mostly like intro lab. What good thing we have over here? First, we can change materials, like in the intro part, air and glass. Right now, air and glass. We can change it to water. Let me slide it to water. So we can turn it on. Well, it's not going to be very important which color of light are you using. You can use red color or blue, whichever you like. It's not going to give you a very big difference, but let's see how color is going to actually change something. I'm going to make my color more bluish. You see that the light bends a little bit more. Now, you probably cannot see it right now. It's difficult to see, but what I'm going to do, guys, I'm going to turn angles. Now I don't need protractor. Actually, somebody is mirroring angles for me. And that's all I need for the lab, right? I'll need to copy index of refraction for both medium and incident angle and emergent angle, right? So now I'm going to move this slider of the color of the light toward the blue region. You're going to see that angle is changing a little bit. See, it's 31.9 and 31.8 and something like this. And originally it was 32. Yeah, it's very hard to see on the picture, but numbers are showing actually that happens. Well, for accuracy of our lab is not going to be super important. So you can actually use any color. You don't need to use a protractor here. Angles are going to be given. What you will need to do. My suggestion is not to choose angle of 45 degrees. Maybe choose something else, but that's up to you. So what you will need to record, you will need to record 2 indexes plus this angle into a table, and then calculate left side and right side of Snell's law to check if it's working. That's going to be all about this lab. And I want you to repeat it 5 times for different pairs of materials. Right now we do have like air and water, and you can always change them, like put air over here and move water over here. And you see the pattern is going to change a lot. I have a question over there. What is going to happen if I start moving and increasing angle, incident angle? You see what happens? What happens to this emergent beam? Maybe you can find some description of this phenomenon. Okay, that's all. Thank you very much for watching this video.